So this is the second session. We're trying to resume our class here. Last time we didn't go into much details about flowcharts. You told me that you know something about it. So normally, typically, we start and end the flowcharts in something similar. Let me try to reduce the screen here. Maybe it's more clearer. Okay. So we call this two parts. The start and the end is terminator parts of the flowcharts. Okay. And we call this part as a decision part. Okay. I think this is clear to you, right?
Yes.
Okay. So do you know what this kind of flowchart is trying to tell us?
How to how the alarm works.
And no. Okay. I mean, is the screen clear to you?
Yes.
Okay. So tell me.
Process that the alarm clock will go through to determine what.
Yes, exactly. Yes, exactly. Okay. So so how many seconds he need to so every how many seconds he need to keep checking the time?
Yes.
How many seconds?
30 every 30 seconds.
30. Okay. So you have a clear understanding of what this flowchart is doing.
Yes.
Perfect. Okay. So yeah, here he just I think that you are aware of what is this doing, right? So do you know what this part of the flowchart is doing here? I didn't hear you.
No, I don't.
Okay, so this specific rectangle, it tell us that this part of the flowchart is defined somewhere else. Okay, so it could be it is possible that this part of the flowchart is actually another flowchart, and then he's only representing it with just a rectangle in this kind of way that he's showing to us. Okay, so sort the list is a list could be. Did you know what the meaning is an array in C#? Did you take arrays in C#?
Yes.
Okay, so it could be an array that need to be sorted, that is unsorted array, and then he do the process of sorting the array, and this process of sorting the array is actually another flowchart. He will keep checking. Oh, this element and the second element after it, they are bigger or smaller than each other. So if they are bigger, then he do something. If it's smaller, he do something else. So that could be a different flowchart defined somewhere else. Okay, not in our current flowchart. Is that clear?
Yes.
Okay, so is that process part clear to you? Should we proceed to the next? Okay, perfect. Okay, so here, okay, can you see here? So the input and output parts of the flowchart clear to you?
Yes.
Okay, we move to the next. Now, so we have a flowchart example. Tickets are sold at a concert for 20 USD. If 10 tickets are bought, then are bought one shot, then a discount of 10% is given. Okay. If 20, let me see here. If 20 tickets are bought, then there is a discount of 20%. No more than 25 tickets can be bought in a single transaction. So let's have a look. Let's have a look here. So are you able to see, or I should try to make it slightly clearer than that?
I can see.
Okay. Yeah. So now I want to understand from you. So what is the purpose of getting n here?
To find out how many tickets they would like to buy.
Okay. And what is what is the purpose of that decision-making part of the flowchart?
Checks if they want to buy more than or more than one or equal to one.
Okay, yeah, but yes, okay, yes, I'm listening.
It's between if the number of tickets they're buying is between 1 and 26.
Okay, yes, okay, yeah, that's good. So if it is less than one, what he will do?
It restarts and then they enter how many tickets again.
Okay, and if it is bigger than 25?
It will also restart and
Perfect. Okay, that's clear. Okay, so now we said that we have a discount when he buys 10 tickets, and we have another discount when he buys 20 tickets, right? So
yes.
that is the part that is responsible for that, right?
Yes.
Okay, so can you tell me, please, what is this part is doing? This rectangle is telling us what?
If they buy less than 10 tickets, their discount is 0.
Okay, so if it's less than 10, right?
Yes.
Okay, and then if it is 20?
If it's less than 20, then their discount could be 0 or 0.1. If it's greater than 10, then it's going to be 0.1. But if
Okay.
it's less than 10, still it'll be 0.
Okay, and so yeah, yes, perfect. And then when he will give the discount of 20%?
It will give him a discount of 0.2.
When?
When it's 20 to 26.
Okay, perfect. And then so he's trying to calculate the cost here. Is it clear to you what he's trying to do here?
He's multiplying the cost by the percentage. He's finding the new cost by
Okay.
removing based off the discounts.
Yes. So so it's clear to you how he multiplies the number of tickets with the
Yes.
current discount. Okay, perfect. So yeah, and then I would say here. So it's clear to you that he will output the tickets here, and then it ends. So the example is clear to you. Should we move to the next?
Okay.
Okay. So I believe let me still try to remember. Okay. So have you seen an if statement before? I believe in C#.
Yes, I have.
Okay. So just a fast recap here. Okay, so this is two different pieces of code. Okay, so we have he's showing to us here how we use an if statement, and then if statement here, be aware that pseudocode is slightly different from Python and from normal programming language. This is just an expressive way to how to say to describe the steps that we need to take to solve a problem. And they call this kind of, so if we have a full piece of pseudocode, okay, we call this an algorithm. And we design the algorithm that before we try to attempt to even write it in high level language like a Python. Okay, so okay, he is giving an if statement here. Every if statement with pseudocode, he's using if and end if and then. In pseudocode, we don't use then, and we don't use end if. Okay, is that clear?
Yes.
Okay. So everything that most of the keywords that we are going to use with pseudocode, they have starting like if, okay, and then they have ending. So it will be end if we are starting with a if here. It will be end case if we are starting with a case here. Okay, if we are using a while loop, or we will have an end while. Okay, is that clear?
Yes.
Okay, perfect. So I would say, do you understand what this if statement is trying to do?
Yes, I do.
Okay, perfect. And what about the case here?
I do, yes.
Yes, so you understand what it's doing, right? Do you
Yes.
do you understand that when wise is triggered?
When it's not A, B, or C.
Okay. Do you understand that only one choice here is executed every time we run the case? So every time we run the case, we either go to execute that or this or this. We cannot
Yes.
execute one of those. I mean, two of those at the same time. Is that clear?
Yes. Yes.
Perfect. Okay, we move to the next. Okay. So did you understand? I believe in C# that you are able to use ors and ands, right?
Yes. Yes.
Okay. Do you know what's the difference between or and and?
And means that both need to be true, while or means that one can be true and the other can be false.
Okay, perfect. So yeah, okay. And do you understand what this guy is trying to do here in that case?
Um, so it starts with if either their height is either greater than 1 or greater than, or the weight is greater than 20, then they um they're younger than 70 and older than 5, they can write.
Yes, perfect, perfect. Okay, that's good. So yeah, let me see. Input check, we have done something similar. So the thing that I'm trying to explain to you here is just one thing here, that you can have a big if statement, and in the middle we are actually able to create another if statement. So the way it looks like here is slightly strange, but that's how, because pseudocode is not a real programming language. It is an expressive language that is close to what we are able to speak in English. So it's just to put our design on a paper, and then after that we start to write a code from it. Okay, so most probably, also maybe not in this exam, but on other exams that you take for A-level language, then he will give you some piece of pseudocode and he will ask you to write Python code for that. And also there is exercises in the books that tell us, okay, he give us a pseudocode and tell us, oh, translate that pseudocode to a programming language. Okay, so can you understand here that so okay, now what this line is going to do? We have taken it last time, right?
Yes.
Okay, so tell me.
It will make allow the user to enter their percentage mark.
Okay, so always in the programming, if you become a programmer one day, always assume that the user is actually going to enter a wrong input. So your code should not crash. If you don't anticipate anything that the user can put, then most probably your code will crash. So he is trying to do what here on the
He
second, on
first
the first
checks
if?
that their percentage mark is a valid percentage mark, meaning that it's between 100 and 0.
Okay, and then here he's trying to do what here?
Then if it's above 50 or above 50,
Okay,
then it is a pass, and if it's less than 50, it's a fail.
Okay, so does this nested if makes sense to you?
Yes.
Okay, good. So did you see a for loop before?
Yes, I have.
Okay, so does this for loops actually make any sense to you?
Yes.
So
It does, yes.
okay, so what is this guy is trying to do here?
So he it will output the star 10 times. And at the
Perfect.
end of the for loop, each time it increments the counter so that it can get to the next time.
Perfect. Perfect. Okay, that's good. Okay, what about here?
This counts the number of stars outputted and will infinitely repeats until, well, in this case, until the counter has reached 9, because it adds the counter each time it runs the code. The counter is added to itself +1.
Okay.
So at first it'll be 0, +1, then it'll be 1 + 1, then 2 + 1.
Okay, perfect. Perfect. So just yeah. Did you? I think you didn't see any repeat until in C#, right? Am I right?
No, I haven't. So,
Okay, so repeat until is actually a kind of loops that we can use. It's possible to use. It's not so we use it when we want to repeat. We want to execute the code here at least one time. Why I'm saying at least one time? Because he only check that condition here after he execute all the code here.
okay.
Okay, so he will repeat until this condition happens, but he will only check the condition at the end. So, and also this method actually is a way to count how many times the loop runs. In the for loop, we don't need to do that because counter always is incremented. It's automatically incremented for us from 1 to 10. But in this case, the repeat, it's just checking only for that condition. It doesn't increment anything. Okay, that's why we need to create
Okay.
our own counter. So can I know what will happen if I remove that piece of code, that line of code from here? If I remove it totally, what will happen?
It'll never stop. It will continually output stuff.
Perfect. That's you have a clear understanding what's happening. Okay, that's clear. That's good. Okay, so we move to the next. I believe you have seen something like this while before.
Yeah.
Try here. Okay. So as I said before to you, we have while and we have end while. Okay, is that clear?
Yes.
Okay. So does this code do exactly the same like this one?
Well, and I think you could say that in the repeat until loop, the condition of when to stop the loop is at the end in the repeat until loop while it's at the beginning here.
Yes, it's correct. So the difference between this piece of code and that while loop actually is only one thing, that the while loop will always check the condition before it's even start. So if you put the counter here 10, this while loop will never run. And if you put it here 10, it will run for one time. This is the difference between these two. Is that clear?
Okay. Yes.
Okay, perfect. We move to the next. Okay, yeah, that is slightly tricky. because yeah, let me share. Yeah. So again, can you tell me please what this guy is doing here? Is this a declaration or initialization?
Initialization.
Okay, so he's not declaring both variables here, right? He's doing it somewhere else.
Yes.
Okay, good. So can we guess what this line is doing?
It will add the total. Well, it's basically saying total plus equals the mark, adding the total to itself and the mark.
Okay, so this is a technique of adding mark to whatever in the total and storing all back into the total. Okay.
Yeah.
But okay, so and these two lines we already know what it's doing, right? We know the output and we know input, how it does, right?
Yes.
So but did you notice something different? He is telling the mark -1. So why this guy would accept a mark of -1?
It's a way for the user to end the code.
Okay, that's good. So you have seen that before, did you?
Yes. Yes.
Okay, in C#.
I think in Python, I'm not really sure.
Okay, yeah. So yeah, that's exactly good. But the trick actually here that is worth studying. Why do you think this guy put the total here in this way? Why he put it here before even he gets the mark?
Um,
So because oh, okay, you need to add some marks to the total. But if you start adding before you get the mark from the user, so that is something quite strange to me, isn't it?
yes.
Okay, yeah, good. So yeah, let us keep our notice and move on.
Okay.
So we both have a concern about why the line of code is arranged the way it's arranged now. So now I already give you a notice before that there is a difference between while and repeat until. Am I right?
Yes. Yes.
Okay. So did you notice here about this code? So the previous code will run for at least one time before it's checking the input mark, right?
Yes.
But here, if this condition is not satisfied, it will not even run for a single time this code inside. Is that clear? That's why
Yes.
you will always see with a while that he have to enter the same pieces of code 2 times. So you see these two, they are both exactly the same.
Okay. Yes.
But he need to do that only when he's using while, because he needs something to check. If he doesn't have any mark at the start to check, then he will never be able to execute that code, and he will produce an error. Okay, so that's why he have to ask the user to input for one time here before he enter inside the while loop. Is that clear?
Yes.
Okay, so we still have a mark about that line. Okay, we keep it with us until we see what we can do. Okay, so actually here he's telling us a definition of an algorithm. So algorithm is a set out of, it's a kind of steps that we need to write or do to complete a given task. Okay, so we can express an algorithm in either flowchart or pseudocode. Okay, before we just to study the code before we even can code it in before we, so the pseudocode and the flowchart is not actually a coding. It's just an expression of the algorithm before we even try to write it in coding of a high level language. Okay. Is that clear? Tojo? Can you hear me?
Thanks. Yes.
Okay. So so is that similar to what we have seen before? We have seen some pseudocode that do something similar to this, or even flowchart. Can you still remember?
There was the alarm clock that's
Yes.
waited 30 seconds. Yeah.
Yes, exactly. So that looks something similar, does it?
Yes. Yes.
Okay. So is that clear to you? Should we move to the next?
Okay. Yes, I understand.
Okay. So let us have a look here, and can you see what is he trying to do here? So if we have a flow chart, are we able to write a pseudocode in your opinion?
I think so, yes. You
Okay.
can see which
Okay. So did you understand what this code is? What is this flow chart is doing?
it's checking, it's asking the user to input two numbers and then telling them which number is greater.
Okay. So okay, I will exit what is here, and then I will it. Okay. So now please tell me what to write.
Okay. Well, you have to first start with the input for the
How many
user.
numbers? So how many numbers we have? How many
Two.
variables? You see, we have two variables, right? Okay. So
Yes.
we already know that we with every variable we need to do two steps. We need to declare and initialize, right?
Yes.
Okay, perfect. So tell me now what to write. We need to declare
Declare
first.
number one.
Num1, like that. Of type.
Yes.
What is the type?
Integer.
Okay. Second.
And then num2, also an integer.
Okay. Next, what should we do?
Num1 is initialized to the input of the user.
Okay. Input to the user. Okay. It's possible. Yes. We are able to do that. So we can say input num1 like that.
Yes.
Okay. What
And
about
then the same with num2.
okay. Yes, we can try that. Okay. What should we do
And
else?
then if
Mm-hmm.
num1 is greater than num2, output num1 is greater.
Okay, we have to stop and then we enter again immediately
Okay.
now.